Hi guys. So in part one, Miss Lowther showed you how to balance equations, and now we're going to take those rules that we learned in part one and apply them to balancing real equations. So what I'm going to do first here in this first example is write out which elements I have. So I have potassium, I have chlorine, and I have oxygen. And I'm going to do the same thing on the product side. So there's potassium, there's chlorine, and there's oxygen. So how many potassium atoms do we have in this first example? There's one. There's also one chlorine, and there are 3 oxygens. We know that because the subscript here tells us that there's 3 oxygens. Now we're going to go to the product side. We see that there's 1 potassium, there is 1 chlorine, and there are 2 oxygen atoms, which is indicated by this subscript. So we see that we're balanced with potassium. There's 1 potassium atom on both sides. There's 1 chlorine atom on both sides, but then the oxygen is not balanced. So what we're going to ask ourselves is, what do these 2 numbers have in common? And the answer is 6. So in order to get the coefficient of 6 here, we're going to multiply this by 2 to get 6. So what we're going to do is write a 2 here. And now you see that these multiply, and we have 6 oxygen atoms. And we're going to go ahead and change our coefficients because now we have 2 potassium atoms here, and we have 2 chlorine atoms. And now we're going to look at the other side, which is unbalanced. So here we want to get oxygen to 6. So we're going to multiply that by 3 to get 6. So we're going to go ahead and put a 3 in front of the oxygen. And then we see we still need, there's 2 potassiums on the reactant side, and so what we need to do here is multiply this by 2, and we're going to add the coefficient 2 in front of potassium chloride here. And so now let's make sure we're balanced. There are 2 potassiums on our reactant side. There's 2 potassiums on our product side. There's 2 chlorines on the reactant side, 2 chlorines on the product side. And there are 6 oxygens on the reactant side and 6 on the product side. So we're golden. We have a balanced chemical equation. So now we're going to move on to the second example. So again, we're going to use the same steps of listing the elements out. So we have sodium, chlorine, and fluorine. So sodium, chlorine, and fluorine on this side as well. There is 1 sodium atom here, so we're going to write a 1. There is 1 chlorine atom here, so write a 1. And there are 2 fluorine atoms. Remember, fluorine is one of our diatomic elements. And on the product side, there's also 1 sodium. There are 2 chlorines, and there's 1 fluorine. So let's balance the chlorines first. So what do these 2 chlorines have in common? They have 2 in common. So we're going to multiply that by 2 and change our coefficient here to 2 in front of the NaCl. And so then we have to change our coefficient, change our table here, and change the number of sodium atoms that we have. So now we have 2 sodium atoms. And then we're going to look at our product side, and we see that sodium is imbalanced, so we're going to change this number to a 2 in order to make this balanced on both sides. So we're going to add a 2 in front of NaF, and we have to change in our table because we just changed the number of fluorine atoms that we have. So we're going to change this to 2. And it looks like everything's balanced. We have 2 of every atom. So, and the blanks here, they indicate a 1. Blank coefficients are just 1. So So we can write that in if we want or just leave it blank. So this equation is balanced. Now we're going to move on to our third example. Again, writing out what elements we have. So nitrogen, oxygen, and hydrogen. Oops, I'm going to write them in the same order just to make it easy. So there are 2 nitrogens, as indicated by this coefficient. There are 5 oxygens in N2O5, but there is also an oxygen in H2O. So we have 6 total oxygens. We have 2 hydrogens, as indicated by this coefficient here. On our product side, we have 1 nitrogen. So we're going to write a 1. There's 1 hydrogen. And there are 3 oxygens. So first we're going to balance nitrogen. We're going to leave oxygen and hydrogen for last. So what number do both of these nitrogens have in common? They have 2 in common. So we're going to go ahead and change the coefficient in front of nitrogen to a 2. So we're going to add 2 there. And then this changes our numbers for all of our atoms here. So there are now 6 oxygen atoms. You see 2 times 3 here, so there's 6. And there are 2 hydrogen atoms. And look, now the equation is balanced. And just a note on this one, be careful because we see that oxygen is in both places. We're going to now move to our fourth example. So again, we're going to write out our elements. So aluminum, bromine, potassium. And you'll remember in the rules that Ms. Lowther shared, we keep polyatomic ions together. So we're going to keep SO4 together as one unit because we see SO4 is on the reactant side and it's also here on the product side. So when I list out my elements, I'm going to write SO4 and keep it all together. So I'm going to do the same thing for the product side. And then write down how many atoms I have of each element. So there's 1 aluminum. There are 3 bromines, as indicated by this coefficient 3 here. There are 2 potassiums, as indicated by this coefficient, or by this subscript, excuse me. And there is 1 unit of SO4, so one SO4 unit. We're going to move to the product side. There are 2 aluminum atoms, as indicated by the subscript here. So 2. There is 1 bromine atom. There is 1 potassium. And there are 3 SO4 units. You'll see this. The polyatomic ion is in parentheses here, and then there are 3 of them. So we're going to write that there are 3 units here of SO4. So first we're going to balance aluminum. So here we see on the product side there's 2 aluminums. There's only 1 on the reactant side, so we're going to go ahead and change the coefficient in front of aluminum to a 2. And now that's going to change how many bromines we have. So we have 3, the subscript 3 on bromine. So multiply that by 2, we have 6 bromines now. So let's balance bromine next. So here we see on the reactant side we have 6 bromine atoms. So we're going to go ahead and have 6 bromine atoms on the product side. And then that changes how many potassium atoms we have on the product side, so we're going to go ahead and change that number to 6 as well. And now we ask ourselves, what's still unbalanced? So we see potassium is still unbalanced. And what do 2 and 6 have in common? We can multiply 2 by 3 to get 6. So we're going to go ahead and add a 3 in front of the potassium sulfate here. So that changes how many sulfate units we have. So now there are 3 because of this coefficient 3 here. And then look, we are now balanced. So I want you guys to do the rest, the last 3 problems as homework. And if you go back to the first page of your study guide, I want you to finish balancing questions 1, 2, 3, and 4 here. So finish writing out the equation and balancing all 4 of them. And we will see you in class tomorrow. Have a good night.